Assalamualaikum and a very good day to everyone. My name is Fatin binti Haron and I am from UITM School of Mechanical Engineering. So today I would like to present about my final year project proposal titled Solar Powered Hydroponic Irrigation with IoT Monitoring System. But before I start, I would like to express my deep gratitude for TS Muhammad Fauzi bin Othman for his passion in guiding me to complete my proposal. These are the key points for this presentation. We will discuss about introduction, problem statement, objective, project scope and limitation, literature survey, methodology, and expected result.
So, what is hydroponics? Hydroponics is a two combination of two Greek words, which is hydro means water and ponos means level. In hydroponics, plants are grown in soilless area and are synthetically supplied with nutrients. First step to starting a gardening hydroponic system is to choose a type of system that suits your need. There are several of hydro types such as water culture, aeroponics, EBB and flow, drip, NFT, and WIP. Now let's see the advantage and disadvantage of hydroponics. The advantage is it can be done almost everywhere because it only takes up a small amount of space and water. It is able to be accommodated in small spaces such as balcony or terrace. Next, soil-borne pests and weeds are no longer a problem because there is an absence of soil. Less insecticide and herbicide involved, and save money spent on nutrient and water because it only takes the exact amount of water and nutrients applied. The saving can be further improved in circulatory hydroponic system. The disadvantages are power and water outage can cause large-scale loss, aspirin and asbestos required for large-scale hydroponics, and it also requires constant monitoring and maintenance.
The problem statement of this project are manual irrigation methods are time-consuming and use a lot of energy. Power and water outage can cause large-scale losses, and also manual irrigation requires constant monitoring and maintenance. The objective of this project are to develop a highly efficient, adaptable, and durable hydroponic system that can be used in all environments and locations. To create a solar-powered smart hydroponics irrigation system monitored by IoT, to make modern agriculture more sustainable, and to develop agriculture in a way that requires the least amount of resources. To create a user-friendly interface that will be accessible both via mobile device or physical interactions. Now we move on to scope of project, an energy-efficient hydroponic system powered by solar energy. Blink application provides remote control and monitoring of system devices via smartphone and the ability for grower to view the data on the dashboard to ensure that the water consumed by plants are smoothly and also the nutrient supply are well balanced. The limitation of this project are ability of sunlight. This project is likely to cost more than it is budgeted for, consume a lot of time to complete and need to be done precisely, lack of knowledge for new software such as Tinkercad, Blink, Octave, laptop capacity cannot support software Katia, so it needed to be rendered.
Moving on to the literature review, many attempts have been made in the past to implement an irrigation system controlled by IoT and powered by a renewable energy source that can operate autonomously. So far, I have been reviewed 12 papers, and there are distinct benefits and limitations associated with each methodology. In one of the papers I have been researched, they're using a soil moisture sensor, the Raspberry Pi microcontroller sense, and control the moisture content of soil inputs to sprinkle them. This is project flowchart. I started my FYP1 with idea and concept development, gathering information related to the study, proceed with chapter 1 to 3 documentation, and proceed half of development of prototype by finding components needed, while the results, data collection, analysis discussion, and full report documentation will be continued in FYP2. For component, I will start with pH sensor. The pH value will be continuously read from the microcontroller. The system will add acid pH or alkaline pH if the pH value is outside its predetermined range, or to balance the pH value until the pH value reaches the predetermined range. For EC sensor, hydroponic plants use EC sensor to measure nutrients concentration or conductivity within a liquid. A microcontroller reads the AC sensor measurement result in the same way as the pH sensor. The system will automatically add nutrients to the installation reservoir until the measurement result fall within the specified range if the measurement results are outside of the specified range. Next, water level sensor. The sensor will inform the microcontroller about the water level. The system automatically instructs the pump to pump water into the reservoir from the water source when the sensor indicates that the level has decreased. Next is humidity sensor. Microcontroller will obtain the result of the air temperature measurement. To reduce the sun's ray, the system will order the server to open the paranet curtain if the air temperature is over the specified range. The system will attempt to close the paranet curtain if the air temperature is normal. For solar pumping systems, solar panels of the required specification are mounted near the pump set. It is then used to charge a battery by using a control circuit. The water pump is powered by the battery by using a converter circuit submerged inside the storage tank. So here is the predetermined range for pH sensor. It is between 6.25 to 6.75. Next, predetermined of AC value. It is between range 900 to 1100. And lastly, is predetermined of water level between range 5 to 7. As we can see, this is the application of soft chart. I have designed it into 4 parts, which is for sensor AC, pH sensor, water level, and humidity. It is expected that the outcome of the project is to develop irrigation that can be monitored via mobile. It is supposed to control the pH value, EC value, water value, and reduce the consumption of water and energy usage. I have been looking forward of FIP2 to test the solar power hydroponic irrigation system to identify further improvement that can be done.
So that's all from me. Thank you so much for your time, and I hope my explanation is clear. If you have any inquiries or any question, please do contact me via the information below. Thank you and Assalamualaikum.